On this assignment, it's called Linear Checkup, we're going to be working on figuring out if things are linear. Well, what does it mean if something's linear? See, here's the word linear right there. And what's inside that word? Inside that word is the word line. So we're trying to see if our data, if our points are going to make a straight line. The way we know that out of a table is when we do delta y over delta x. The change in y over the change in x has to be the same. It has to have the same slope. So let's go down here and let's look at the first one. Delta y, the change in y. I'm going from 0 and I'm going down to negative 12. That means I'm going down 6. This one is down 4. Oh, and that's not a 4. Let's try that again. So negative 4. And this one is negative 2. Delta x, I'm going from negative to positive, so I'm adding, I'm going up, plus 3, plus 2, plus 1. So now what we have to go and see, we have to do delta y divided by delta x. Okay. Negative 6 divided by 3 is negative 2. Negative 4 divided by 2, negative 2. Negative 2 divided by 1 is negative 2. Well, these numbers are all negative 2. They are the same. That means that my data, that letter A, is linear. Okay, but it says circle the table or tables. So we need to check these other ones. Delta y, the change in y right here, I'm going up, plus 2, plus 4, plus 8. Delta x, plus 3, plus 2, plus 4. Delta y over delta x, I have, whoops, I don't know why I did a line there. It is 2 over 3. That's as low as it goes. Then I have 4 divided by 2. That's 2. Okay, wait a minute. 2/3 and 2, already I know they don't match up. Well, the next one said 8 over 4. I am just having a hard time writing. 8 over 4, which does equal 2. These two are the same, but all three of them are not. This is not linear. It will not make a straight line. If you don't believe me, graph the points. Oh, I don't want to circle it. Silly me. The next one, letter C. Delta y minus 1 minus 3 minus 1. Delta x plus 2 plus 6 plus 2. Well, let's see about this one. Negative 1 over 2. That reduces to negative 1/2. Then we have negative 3 over 6. That reduces to negative 1/2. Well, we're looking at these. They are all the same. So yes, this is, oh, I didn't mean to write with that. This is linear. And how do you know in a table that something is linear? That's what it's asking you down here. You know when the change in y over the change in x is the same. Next, it says circle the equations that show a linear relationship. It says explain how you can recognize a linear relationship. Well, one, we're going to put it in the calculator. Put the equation in y1 and graph it. It is linear if it is a straight line. Okay, so which one of these work? Let's grab my handy dandy calculator. We'll go up here. First one I'm going to put in there, go to y equals. I'm going to put in there 1/4. 1 divide 4 x and press graph. Some people say, oh, it looks jagged. It's just kind of the way the calculator graphs it. But yes, this is a straight line, so this one works. Let's look at the next one. It just says y equals 4, so we'll just put in there 4 and press graph. Sure enough, it makes a horizontal line. So yes, this one works too. You may want to just make yourself a note that this is a horizontal line anytime it has y equals and just a number. The next one, oh, move this over, come on, says 4 divided by x plus 3 and press graph. Oh, that makes two curves. No, this is not linear. This one is no. The next one, go to y equals, and it's negative 4x and press graph. It is a straight line. So when you have equations on your quizzes and tests and they want to know if it makes a straight line, put it in the calculator and see. Next, write the name of the graphs or graphs that shows a linear relationship. Remember, linear means straight line. This is a curve. It's not that. B, yes, B makes a straight line, and so does C. How do you know they're linear? Because they are straight lines. Next, it says draw the linear parent function of the graph below. Okay, very important that you know what a linear parent function is. Linear parent function is the beginning function. Oh, where'd my yellow go? Try again. It is y equals x. That's it. It's the base function that we compare all of our equations. So I guess it says to draw it. What's the equation? I should have written it over here. Y equals x. You're going to have that memorized. If you want to see what it looks like, let's go in the calculator and put in there y equals. Go y equals x and press graph. Okay. It goes through 0, 0. You can look at the points. Oh, let's go back to 0 here. I have 0, 0. So here are the points, and you can plot these points like negative 2, negative 2, negative 1, negative 1. So as I go and look here, I know I've got 0, 0, over 1 and up 1, over 2 and up 2, over 3 and up 3, over 4 and up 4, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Okay, so these are going to make your straight lines. Your linear parent function will look like this. There it is. Next, determine which of the following situations if they're linear or nonlinear. So this says Kyle is a lifeguard at a local pool. He earns $5.75 each hour he works. One way you could do this is to go and try and figure out a table. For working 1 hour, he gets $5.75. Working 2 hours, oh, what is that? 10, 11, 11.50. 3 times 5.75. My brain is not working today. Let's just go here. 5.75 times 3. 1775. I'll just double check my math here. Oh, good. All right. 1775. Can you write an equation for this? Y equals 575 times x. You can even put that in the calculator, but yes, that, and see if it makes a straight line. Yes, that is linear. The next one, cell phone charges 35 cents for each minute and an additional $25 fee. Well, if we went and we could either one, draw a table, and it says they charge 35 cents for each minute and an additional $25 fee. So at the beginning, they charge 25. 1 minute, it's 25.35. 2 minutes, 25.70. You can go through and try and find your equation that way. Or you can see that you have 35 cents times each minute plus 25. You could put that in the calculator. It will show you that it is a straight line. So it is linear. This one down here. Matt is counting the number of fish in a pond. He finds that the number of fish triples each month. Okay, so if I started out, say I started out with 2 fish. After 1 month, it triples. Triples means times 3. 2 times 3 is 6. Let's see if I can move this up a little bit. Second month, it triples again. 6 times 3 is 18. 3. 18 times 3. Oh, what is that? 4 and a 2. 54. Well, to see if this is linear, now that we have a table, delta y over delta x has to be the same. This is plus 4 plus 12. Oh, what is 54 minus 18 here? 36. So now I have, and these are all plus 1. So I have 4 over 1, which is 4. 12 over 1, which is 12. These are not the same. This is not linear. Let me give you a hint. If something uses the word triples or doubles, these are not linear. I was just trying to be cool like this, but those will always tell you that they are not linear.